Hello, my name is Dr. Nicholas Dogris, and this is the basic walkthrough for our new TDCS tACS system that we are now releasing. Before I begin, I'd like to say thank you to everyone who pre-ordered. Um, your pre-order makes it possible for us to mitigate production costs and to continue R&D. So thank you very much for your support and for your enthusiasm. Now with that said, let's get going. The purpose of this webinar is to get you up and moving with the TDCS ACS system. It is not an end-all. I will be training on this unit with all future trainings coming up in the basic and in the advanced trainings that I teach. So there's a lot that can be done with this system. I'm going to be touching on just some of the basics. I suggest that you go slow. Take your time to get acquainted with this new device, as it is very powerful and a very good addition to the NeuroField system. Now with that said, this system can be connected in a number of different ways, but first let's look over what you received. You should have received a CAN bus adapter that can plug right into the back of the unit, and on one end, which looks like a telephone cable, and the other end, which is a USB cable that goes right into your USB port. If you've installed the software correctly at this point, the CAN bus adapter will be recognized by your PC and the driver will be loaded automatically. You're also going to notice that now we have released our field replaceable battery solution. This is an ion lithium battery that is in the back of your unit. You'll see a little ribbon that will allow you to grab that and you can pull it straight out of the unit. The battery has a little LED indicator on the battery where you can push a little button and you'll see the indicator light up, which tells you the current charge of the battery. If the indicator lights up all the way, all the LEDs turn on, then you have a full charge. And if you only see one LED, that means it is almost dead. So battery hygiene is important. The batteries have a lifespan. It will die eventually. However, if you take good care of it, it will last a long time. Typically, the battery can last about 1 year, maybe 2 if you treat it right. Discharging the battery appropriately is important, and establishing good memory for the battery is important. Batteries have a memory, and so when you turn the unit on, keep it on all day for about 8 to 10 hours, and then shut it off at the end of the day. This will, whether you're using it or not, this will allow you to discharge the battery appropriately and then be able to put it in a charger overnight and let it recharge. And that way the battery will eventually develop a memory for 8 to 10 hours of use. That's about appropriate for the kind of battery that you now have in this unit. The batteries, as you can tell, are field replaceable, meaning that you can replace them. You can purchase additional batteries from us, and we can have them on hand so that you will never have any downtime. Essentially, if a battery dies, you can have another one on the side and be ready to go at any given time. Now, just like our other NeuroField products, the unit plugs in to the CAN bus adapter. However, it also has the ability to be daisy chained directly into the existing NeuroField system. So you take a little USB adapter, a RJ45 network adapter, excuse me, and you plug it into the back of the unit and you can daisy chain it to other units. And when you plug the CAN bus adapter into the back of the unit, you'll see there's two RJ45 ports there. Either one can be used. It doesn't matter. They're both inputs and outputs, and you can daisy chain either one to another unit. However, there are some rules. You can only chain together 3 units at one time, meaning that you can only have one X3000, one TDCS ACS, and one Q20 on one bus. You cannot have 2 X3000 units and the TDCS ACS on the same bus. Currently, the software doesn't support that configuration. You can only have one of the X3000s and one TDCS ACS on the bus at this time. Now, this may change in the future, but for now, that's the way it is. So please make sure you configure the system in that way and connect it correctly. If you look at the front of the box, you're going to see two little touch-proof connectors there. Their inputs, and one says neg and one says pos, and that's obviously for negative and positive. In the TDCS ACS world, the positive is associated with the anode, whereas the negative is associated with the cathode. This is important when you're running the unit in DCS mode or DC mode, because DC stimulation is only one polarity. It's either positive or negative. The energy goes in through the anode and out through the cathode. So it's a direction in which the power flows. It's unidirectional, one direction. So in through the anode, out through the cathode. And we'll talk about why that's important in a little bit. If you run the unit in alternating current mode, ACS, then the energy will flow in through the anode and out through the cathode, but back in through the cathode and out through the anode. So in other words, it's bidirectional. So it doesn't matter in which place you actually have the anode or cathode, because it is bidirectional. They are interchangeable for each connection. The touch-proof connector, as you might tell, looks very much like an EEG electrode connector that we use for standard EEG applications. If you make that assumption or notice that so far, you are correct in your assumption, which means that you're able to plug in regular EEG electrodes into the front of the unit, and we'll talk about how to do that in a little bit. The unit also shipped with little ECG electrodes, and you will see that there's two different sizes. And these little electrodes are designed to snap on to the cables that come in the package, and they peel off and expose a little foam hydrogel there that's sticky. And you're able to place those directly onto the skin where it will make a good connection. So you'll have two bags of foam electrodes there, and those are pretty good. There's small ones and big ones, and basically the dispersion of the electrical field is more focused with the small one, but it can be more prickly and intense for a person, whereas the large one disperses the electrical field in a larger area and can be easier to tolerate for some people. Now, as I was talking about a moment ago, you have AC and DC capabilities with this unit. AC is alternating current, DC is direct current. AC is it basically is a waveform, and what you have in the unit is you have the capability of assigning a sine wave, sinusoidal wave, a square wave, or a triangle wave. Those waveforms are going to alternate in from positive to negative polarities, and again, it's going to change the both the anode and cathode are bidirectional at this point. So it goes in through the anode, out through the cathode, back in through the cathode, and back out through the anode. So they alternate in current. DC is simply, it's not a waveform, it's simply a polarity, and it's going to be at a certain level. So it's going to be positive or negative, and again, that is unidirectional in terms of the current. It goes in through the anode and out through the cathode. All right. Now, we've been playing around with different kinds of placements with the unit. The research is out there on TDCS, and there's some research on tACS now with alternating current. I tend to be using alternating current more so than I have been using DC current, but there are some cases in which DC current is preferable. But the majority of the cases I'm using ACS settings, and I find that they just seem to be more effective for a lot of different reasons. But I'm sure that as we use this device more and more, you're going to see that ACS has a very powerful effect on people. Now, the placements we've been using have been associated with the mastoid. In some cases, we go mastoid to mastoid, and we go straight across between those two placements. And in other settings, we use the mastoid to FP1. The mastoid, so I could go left mastoid to FP1, which would be directing that current through the left hemisphere. I could go mastoid to FP2, which would cross over to the right hemisphere if I went left mastoid. I could do FP1 to FP2, F3 to F4, F7 to F8. All those are available skin areas that you can typically put the foam electrodes on. But one of the things that's coming out in the research right now is high definition TDCS, ACS. And what they mean by that, and what I've seen, is that a direct electrode is placed on a 1020 location. One of the studies that's in your NeuroField documentation folder now talks about fluid intelligence and how to increase fluid intelligence. And what the researchers did was they placed an electrode at P3, parietal 3, and they put the anode on P3, and they put the cathode on FP2, and they ran these studies and they tested fluid intelligence changes in people, and they found that fluid intelligence improved with that specific electrode location. So you can use electrodes and go directly over areas. One of the things that I've been working on with some of the autistic kids we're working with is FP1 to the mastoid on the left side. We've also done it where we've done F3 to T5 in order to hit both Wernicke's and Broca's areas, for instance. So you can start targeting regions and try to tie them together essentially using the DC or the AC. Now, the thing about anodal stimulation versus cathodal stimulation is that the anode is supposed to be something that stimulates that area, whereas the cathode is supposed to be inhibitory. And this is what I've understood in reading the literature, and I'm still trying to understand exactly what that means, because in our preliminary studies in which we've examined these new modes, we've seen significant connectivity changes in alternating current stimulation. And so when it's alternating currents, you're supposedly getting a stimulatory effect and an inhibitory effect from each location. And that seems to change connectivity and phase quite dramatically. I'll be showing you something a little bit that demonstrates that. But the placements are pretty interesting, and I suggest that you play around with some different things. In your NeuroField documentation folder, if you have the newest version of the software installed, there's some new studies that got dropped into that folder. One of them is entitled TDCS.pdf. I really suggest that you take a look at that specific file and read it through. There's a lot of great information about stimulation technology, the evolution of stimulatory technologies, and specific chapters on DC and AC. So it gives you a lot of good information that will help you to understand what you have in your hands right now. With that said, two of the major areas that I see almost an immediate application, and the research shows this, is in depression and anxiety patients. People with depression respond very nicely to DC stimulation, where you place the, if you want to do DC, you would put the anode at F3 and the cathode at FP2. Anode at F3 and cathode at FP2, and you would run direct current stimulation. And usually you can do it in manual control at about 10 hertz. Now, the same can be said for anxiety. Anxiety has been shown to be also greatly changed by the use of DC stimulation, and you can go from F3 to F4, and then with the anode at F3 and cathode at F4, or you could do alternating current at F3, F4, and also get a significant response. Now, because of what I've been seeing in the literature and some of the patients that we have tried this on, I'm pretty sure that we're going to see some really good effects for autism, Asperger's, Alzheimer's, TBI, and learning disorders. And it's because of the type of coherence effect that you can get and the phase changes that you can get. They're quite dramatic. So some cautions. Number one, don't use this unit with a seizure disordered patient or anybody with epilepsy. At this point, I think that it's really strong and that it may be too powerful for a sensitive seizure patient and may have the possibility of actually having, causing a seizure. Now, that doesn't mean that we're not going to look at this in the future, but for now, I would suggest not using it with people with seizure or epilepsy. The unit is a 2.5 maximum output unit, and while I do not think it would have a negative impact on a person with a pacemaker, I don't want to test that theory at this point in time. So with people with pacemakers, do not use the unit. If a person has a TBI or a stroke, I suggest that you give them a minimum of 4 weeks of recovery before trying either TDCS, ACS, or electromagnetic stimulation. It's always a rule of thumb to give the brain time to go through its healing process. If we interrupt that, we could stress the brain or push it in a way that may make it more difficult for a person to recover. So give them time to heal. After 4 weeks, if they're still having an issue, then I think it's appropriate to start treatment. But starting too early, I think, is premature. You got to give time for the tissue to heal. When we begin treatment with this unit, always begin at a very low voltage. The database starts at 0.5 milliamps, but for some people that is too strong, and you may need to override the output and make it 0.1 milliamps. The unit has the capability of going down to 0.01 milliamps and as high as 2.5 milliamps. Those are the caps on the unit, 0.01 milliamps to 2.5 milliamps. You can override, when you pick a protocol, if you want to test the waters, you can find a level that works with a person and then increase it to where you're getting a clinical effect, but it's not too intense for a person. And intensity can be felt via what we call a shutter effect. Some people may see what it may look like a blinking light or a strobe light, and that may be that you're using a stimulation between around 10 and 20 cycles per second, which can have a strobe effect and may be uncomfortable for a person. If they have that response, it's important to lower down the voltage so that it's tolerable for them. And for other people, they may feel a pins and needles kind of feeling or a slight discomfort right under the electrode. And again, this may mean that they're sensitive and to lower the stimulation. Of course, with children, I think it's mandatory to start at 0.1. Even lower than that if you want. You can start at 0.01 to where they say they don't even feel anything. That also will have a clinical response, but won't be overwhelming for a little one. So always start at low voltage. Now our current NeuroField version is 9.5.2. All versions from this point on now include a new TDCS tACS database. In this database, I've compiled together some cross-frequency coupling protocols, some standard 1 to 4, 1 to 8, 12 to 15, 15 to 19 protocols, So there's a number of different protocols that I stacked together into this database. I think there's over 30 of them at this point. Database is no doubt going to grow as we start trying different combinations of stimulation. Cool thing is that the database can be used as a standalone with the TDCS tACS unit. However, if you have an X3000 linked to the system, it will see the X3000 connected, and the database has protocols that are set up so that you can do cross-frequency coupling with the pulse electromagnetic stimulation while simultaneously giving a straight tACS stimulation. So that's kind of neat when you compare these two different kinds of stimulations together. We added a manual control, which allows you to just select a patient and then pop it open, and you can give a single frequency. You can run it in 3 different modes. We have continuous tACS, or alternating current, so that's continuous. We have pulsed alternating current, and then we have the DC mode, which you can go either positive or negative polarity. And that's really cool. And within each mode, for the pulsed and the continuous ACS, you can choose between sine, square, or triangle wave. Now, it's important to realize that the most aggressive treatment is a square wave with the ACS unit. So if you choose square wave, you're going to be giving the highest output. The next in line is the triangle wave, which is the second to highest output, and the third in line is the sine wave. Now, sine wave is a nice smooth stimulation, and it's one of the waveforms that I tend to use the most because people tolerate it well, and it can move a person very quickly and easily with little discomfort. It's really smooth, and so I would suggest using sine wave. However, with other people that are really depressed, you may need the power of a square wave in order to move the brain out of a depressive state. With those 3, you can rank order their power from square, triangle, and sine, with square being the strongest. We added the ability to run the TDCS tACS unit with the dehabituator. So you can set a range as you normally would with the dehabituator and run it. The rules are now that the dehabituator, when it's hooked up to the tACS, is going to allow you to run frequencies from basically 1 hertz to 1,000 hertz. So you can choose between those ranges. The amount of stimulation or intensity and voltage with milliamps is 0.01 to 2.5 milliamps. You can set up durations from 100 milliseconds all the way up to 60 seconds if you want. Now, I suggest that you use short pulses. Anything over 10 seconds is really too long in my opinion. I think the brain habituates to it and it doesn't have as good as a clinical effect. So I say anywhere from 100 milliseconds to 5 seconds is usually long enough for the dehabituator. We also added the ability to use this new unit with the RTC procedure. So now if you want, you can run EEG synchronized with the TDCS ACS with our Q20, where a stimulation is given, EEG is read for 4 seconds, Z-scores are generated. If the brain is generating the Z-scores that fall within the thresholds that you set, then a person is given a reward tone. So again, like the previous electromagnetic stimulation procedure, we are now using that with the TDCS tACS system. It's all synchronized in the very same way. What's really cool about it is you can actually use the electromagnetic stimulation with the TDCS tACS unit simultaneously. So you can give an EMF stimulation and an ACS or DC stimulation simultaneously for X amount of time, and then it'll shut off, and then it'll read EEG, generate Z-scores, and either give a reward tone or not based on whether or not the threshold criteria was met. Again, we've kind of upped the ante in terms of enhanced operant conditioning. The cases that I think are going to respond really nicely to this are people with depression and anxiety. or people that have really severe hypocoherence or really severe phase lag issues. One of the things that we're noticing is that there seems to be a clinical effect between the pulsed ACS and the continuous ACS. Pulsed gives a little break in between stimulations, which gives the brain to have a little bit of recovery time. And if you run it in manual mode, you'll see how it runs, where a little pulse is given, then it shuts off, a little pulse is given, shuts off, and there's time in between each pulses. The real-time Z-score procedure naturally has that break built into it. So if you give 4 or 5 seconds of stimulation, it shuts off for 4 or 5 seconds to read EEG and then generate the Z-scores. That gives the brain a little time to respond and recover from the stimulation. And I think there's a really powerful clinical effect associated with that, which is why I really like it. Also, it's creating a learning regimen for the brain to adhere to. I think EMF and all the stimulating TDCS, tACS stimulation technologies are wonderful. However, I also believe that by themselves they'll have X amount of clinical utility. For some people, it does the trick and it's good to go. But for other people, we need to generate a learning paradigm that allows the brain to learn how to establish these new pathways and to remember how to maintain that configuration that we're creating with the stimulation technology. That's why the real-time Z-score procedure is really good, because it is a learning operant conditioning paradigm. And with people that have a poor premorbid history, I think that this procedure is really good. So when you have somebody that, for instance, a child with autism or Asperger's or ADHD, where they've never had a good period of functioning, their premorbid history is poor, which means that the brain doesn't know how to reorganize itself after it's been disentrained, which means we have to show it how to entrain. And so this procedure can show the brain how to entrain, but also generate the learning that's necessary to deepen the learning, and get longer term effects. So for whatever it's worth, try different combinations of this. Now we've just introduced a whole new animal to our entire menagerie of stimulation technology, and I think what's really cool about it is that we're going to see how the layers work together. I really like using the tACS on the mastoids, on the right and left mastoids, where you're passing current back and forth through the hippocampus and through the limbic system, while simultaneously giving stimulation directly to the cortex with electromagnetic stimulation. That has a very profound effect on people. And again, when you're running real-time Z-score, it can be incredibly powerful. Another way to do this is to run NeuroGuide. You can run NeuroGuide while having the electrodes either on the frontals and the mastoids or through the mastoids directly. And you can set really slow frequency stimulations at 0.01 or 0.1 cycles per second that don't get picked up by the EEG because they're below the high pass filter, which is going to cut off at 0.5 cycles per second, which means that the EEG won't be corrupted, and you can generate real Z-scores, real EEG in real time and get some significant changes. But what you're doing essentially is you can use polarity shifts at real slow frequencies to offset the brain or disentrain it. And we can talk about what that looks like in the future. I will be doing webinars on these topics. Okay. So let's look at a little bit of data before I jump into the software here. Here's case 1, 22-year-old female. These cases are not mine, by the way. They were done by another NeuroField practitioner. This is a pretty significant, hard-to-move case. And as you can tell from these diagnoses, this person has a number of different kinds of problems. And the focus of treatment was to really change conductivity. And alternating current was used at 10 hertz on the mastoids for 6 minutes at a time. at a pretty high setting, 2 to 2.5 milliamps over the course of 1 hour. So, 6 minutes would be given, then it'd be turned off, and then a little bit of rest time, and then be turned back on again. The report that was given here is that she no longer experiences anxiety. It's pretty much abated, and that the hopelessness and depression reduced. So let's take a look at that. On the left is the pre, on the right is the post. And of course, if you look at this connectivity change here, you can see these massive hypercoherence in theta, beta, and high beta. And, where it pretty much resolved. And below it in phase log, which is really fascinating to me, is you see these significant phase changes. And I think what's really important here is that phase underlies the entire function of the EEG. If you can change phase, you change everything above it, essentially. And here you can see these big phase changes, and we start to see this real, the phase lag in alpha really starts to present itself, and it's in that frontal lobe. You see where alpha has increased. Of course, this person did receive 10 hertz, so what I would expect to see over a period of 72 hours or so would be a regulation of that alpha if another key EEG was taken. But you can see on the left map here that high beta is locked in a high mode pretty much, and it's at least 2 standard deviations above the norm, probably higher because this is the summary page and things don't get they get averaged out. So, and the z-scores are set from 4 to -4. So the yellow really does represent 2 standard deviations at the anterior cingulate, posterior cingulate, and at P3 there. So we do see some really significant increases, and they pretty much resolve in the post map there. So that's really significant. It broke loose and it regulated itself, and 10 hertz was given, and you can see that it was given through the mastoid. So T3, C3, all of those areas are increased. But again, I think that would be a temporary effect as the brain would regulate itself. Here's another case. A 52-year-old man came in because of brain fog. Again, not one of my patients. He had hit his head in the early 20s, and I guess he had a rough accident where he fell, and he hit the right side of his head, and there you see a theta spot, which I'll show you in a second. One session of ACS, alternating current, using the 15 to 19, 40 to 80 cross-frequency coupling chirp protocol, which means the chirp means that at 40 to 80 hertz, gamma is only put on for just maybe 100 milliseconds. The person received this for 20 minutes. And here's the same map taken within the same hour. And this guy said he felt really good afterwards, more awake, more energized, alert. And if you look at 7 hertz on the left map there, you can see that it's 4 standard deviations above the norm where he sustained the injury, right there at T4. And post, it's completely gone. Now, this is a protocol where the coils and the TDCS were used to regulate the excessive theta, and there's a real good response there, which is great. The unit can work that quickly, and when you do pair it with electromagnetic stimulation, I think you get an exponentially stronger effect. However, it is standalone as well. Okay, so with that said, let's jump into the software and take a look at it. So I'm starting up the new version of NeuroField, and you can see this is version 9.52. And when you click on the drop-down menu, you'll see that NeuroField TDCS Database is now there available for you. So select it. Now, there's one caveat here. If you have a TDCS unit connected to the computer, you will have to run the TDCS database. If you try to load another database, the software will recognize that you're attempting to do so, and it will say you're not allowed to do that if you have a TDCS unit connected to the system that is powered up. We do that for a specific reason. We do not want stimulations being given above 1,000 cycles per second because it's going to generate a lot of heat. And in other NeuroField protocols, the electromagnetic stimulation is given above 1,000 hertz, and in some protocols, and we do not want that to happen at this point in time. It is a way to protect the patient from getting overexposed to stimulation, and the faster the spin, the more heat that'll be generated, which could lead to tissue damage. So we don't want anything longer than 1,000 cycles per second. Now on the slow end, which is really cool, is you can go down to really infralow frequencies and actually generate them for real. And that can take you down to 0.001 cycles per second. And that's a really long stimulation, but you can do it with this system. Now I'm going to click through this, and I'll click continue here. On the left hand side here, you can see that the primary stim unit that was found was a TDCS unit, and then the Q20 was also found here. Now if I had an X3000 connected to this chain, which I do, and I had it on, you would see that it would be discovered as a secondary stim unit. For now I'm just running the TDCS. Okay, and I go in here. So now when a TDCS ACS unit is connected to the system and it's powered up, you will see this little button here that appears. It says TDCS manual control. This is also the control for the ACS as well, for manual control. I'm going to click into this. When I do it, it tells me you got to select a patient. And so, yep, we want to store everything. We've done a lot of changes in this software version to streamline the patient database and make writing notes and all that fun stuff much more fluid. So I'm going to select the patient here, just a fake patient, and open this up. Now on the manual control, what you're going to see here is some different things that you need to set up before you can do this with somebody. The first thing first, you have to select your sites. So let's say you decided you want to work on executive function with somebody and you wanted to give stimulation between F3 and F4. Well, you certainly could do that. And what you want to do is clean the skin at both sites, connect the foam pads they snap right onto the electrodes, remove the little backing to the foam pad, which will reveal a sticky gel that you stick right to the skin. If you do not have it connected right, you won't see the appropriate waveform get created on our little measurement graph. Connections and cleaning is very important. So if I drop down here, you say this little control and monitor menu, and I click on this, you're going to see 3 ACS pulsed waveforms that are available to you, 1 DC waveform that's available to you, and then 3 continuous ACS waveforms that are available to you. So let's start with sine, and I'm going to go down to tACS continuous sine and click on that. Now that's the waveform that I want. I want it to be continuous, and I want it to be a sine wave. Now all I have to do is pick my frequency and the desired output that I want to use. So let's say I wanted to work with somebody, like I said, executive function. I could go to 15 cycles per second. If I wanted to increase that low beta, I could set that output to 0.5, or if in ideal situations, what you want to do is start at 0.1 and then work your way up. So once you make that change to the voltage, you have to update the frequency amplitude, because if you see here in this box, it says calculated amplitude is 2.5. So right now it doesn't know what you have set here, and what you want to do is just click update amplitude, and it changes it to what you actually set here, or pretty darn close to it. Once you have it all set up and ready to go, you just click on start, and the unit will automatically start to generate the waveform. Now on the vertical axis here, you can see some numbers from -4 to +4. This is a milliamp voltage scaling. So if it's 0 to 4, those are positive milliamps, and 0 to -4, those are negative milliamps. Now if you notice, this is alternating current, so it's going above and below, from positive to negative. And it's oscillating at 15 cycles per second. It's going to continue to do that. Now, if the unit wasn't plugged in or wasn't connected correctly, you wouldn't see this waveform. And so what I'm going to do here is I'm going to stop this, and I'm going to increase the voltage to 1 milliamp, and I'll update it. I'm going to restart it. And now you see it at 1 milliamp. And if you can see here on the scaling, it's 1 to -1. And that's what you should see if a person's hooked up correctly. If it looks like the voltage is lower, that means that you either didn't clean the area or didn't attach the electrode correctly. Now, let me just show you what that looks like. I'm pulling out one of the cables from the front of the box. And as soon as I do that, the connection's broken. The circuit is broken, essentially. And the unit is measuring the amount of voltage that actually makes it through the head. So what you're seeing here is not a simulation, but it's an actual measurement. I'm going to plug it back in, and what you start to see, again, is the actual measurement that comes out. And that's one of the cool things about our current scan method here. You actually know what's going in, and you can see it. You can verify it. So you want to check it as it goes. Now, current session times should range between 10 and 20 minutes maximum. I wouldn't go any longer than that unless you're using pulsed stimulation, where you do pulses for 5 minutes or so, and then you stop it and let the person rest for maybe 2 or 3 minutes, and talk to them for a little bit, and then give them another set of pulses. As long as there's some downtime in between, you can give a series of pulses that I think are very beneficial. But don't do it continuously more than 30 minutes. Now, as it's running, you'll see our little clock here on the main stim launch pad is kind of clicking away. It's counting the time for you. And so that way, when you look in and you want to see how much a person's getting, you can see how long they've actually been running. The scan counts on the manual control are just telling us how many times has it run this scan through the actual measurement page. Once it's all done, then or you're done, then you want to click on stop, and it will shut off the system. Now, if I want to, I can do direct current. So I'm going to go to that and click on that, and I can set it at 1 milliamp. Watch what happens when I click on that, and there it is. Now, unlike alternating current, direct current isn't a waveform. It's simply current running at a specific output, a specific milliamp output. And as you can tell here, we're roughly 1 milliamp, and it's positive, okay? We're running at the positive, so it would go in through the anode and out through the cathode. If I wanted to, I could invert that. I could stop the stimulation. I could go in here and make that number -1, click update frequency, and then run it. And it should run it at -1, which it's doing right now. And so you can actually see how the system can be inverted. And that's kind of cool. Okay, so one thing that you can do is you can set it at 0.1 hertz. Set the voltage. Say I set it at 1 milliamp. And let's say I grab continuous sine wave. Update it. Now what it's going to do, it's going to create a waveform at 0.1 cycles per second. And if you're running EEG and you want to dislodge the brain from a stuck state, or bump it, so to speak, you can start it, and it'll begin to oscillate from 1 milliamp to -1 milliamps at a very, very slow rate. And if you can see that polarity shift is what is typically trained in infralow trainings, except we can actually do it here and generate the real waveform. And when you do this, when you're training, you're essentially bumping the brain out of a stuck state, which is going to change the phase and coherence in the EEG. Now, you can do it for a period of time. And remember, NeuroField works side by side with NeuroGuide, so you could have the Q20 running on another CAN bus and while you're giving this. Now I'm going to stop it, and now that's done. So then, if I want to, I could do pulse modes. And let's update that 15 hertz, and let's go to a pulsed sine wave. So now I have it set up pulse sine at 15 hertz at 1 milliamp. Now the pulse interval is going to be 2,000 milliseconds, and you can use this. Watch what happens when I do this, and you can see how the system is only going to give that pulse for every 2 seconds here, and it gives just a really brief pulse, and it's giving 2 cycles. So you can see 2 15 hertz cycles appear, and with a 2-second interval between them. Now this pulsing effect really has a powerful effect on the brain in terms of moving it out of a stuck state. There's a natural pause that's built in between it. Now watch what happens when I decide that I want to stop this. And what I'm going to do is I'm going to say, give me 10 pulses in between. And I update. So now let's do it again. And now you can pulse it for longer periods of time, and with a 2-second interval in between them. This can have a very powerful effect on changing the brain. And let's stop it again. Let's make it 40 hertz. So I'll change it to 40 hertz, update the amplitude, and start it. And then you're going to see a little gamma burst given here. And again, I can bring down the amount of cycles and play around with, how many cycles I actually want to give. Do I want to give more or less? And again, we're just giving 10 here. So this is kind of cool in terms of giving little bursts. And with the gamma cross-frequency coupling research out there, this is pretty exciting when you can actually burst or chirp gamma. So another thing to look at. Okay, so that's the manual control in a nutshell. Very straightforward, very easy to use. When the system is on, you will see that this little window opens up, giving you the actual scan, and then you're going to see the little LED on our software turn on here. TDCS ACS is on, and you're going to see that it's all running. When you shut it off, then the measurement screen disappears, and this display is off. All right. Now it's important to make sure you shut the system off before removing anything from a person or putting anything on. Always make sure it's off. That's manual control. So now let's go into the actual protocols. So if you go into the protocols, you're going to see that the database here is quite intensive. You're going to see CFC protocols. Those are cross-frequency coupling protocols. You're going to see the chirp protocols that are all in the CFC database. And then you're going to get down to the good old school NeuroField protocols, 1 to 4, 4 to 8, 9 to 12, 12 to 15, 15 to 19, and then the rocking ones that go up and down and so forth. So you can choose any of those. And then you're going to see some new ones that I just recently developed that take really, really slow wave 0.1 ACS stimulation and pair it with 1 hertz and also pair it with gamma at 40 to 43. So this is designed all for ACS at 0.1 and then paired with EMF 1 to 40 to 43 in gamma. It's another way of creating a kind of a harmonic coupling between network hubs. And of course you'll see the dehabituator at the bottom. Don't touch that as normal. It's not where you run it. So let's look at this and see what actually happens if you give one of these protocols. So I'm going to go to 5 hertz, 40 to 80, and let's take a look at that. If you look here, you're going to see that it runs for 27 seconds, and the number of loops is 1. The waveform that it defaults to is square. Now, again, remember, square is the most intensive with tACS, TDCS. So I tend to use a sine wave more often than not. You'll also see in the drop downs here placements where you're going to put stuff. And we have mastoid in there now as one of the drop downs. We've added OZ and FPZ just in FP1, FP2. So if you pick something with the ACS unit, the first stim generator, the primary stim generator, is where you want to put your ACS placements. If you have an X3000 connected to the system, a secondary stem generator will show up here, and then you want to be able to select those sites where you put the coils. In this page now, you're going to see if there's a TDCS unit hooked up, this will be visible here. There's an amplitude override. The first box that says enable is associated with the amount of milliamp output. All right, and I've enabled it, which would override whatever output is set in the CAN protocol to 0.1, and you can click in that box and change it to what you want between 0.1 milliamps to 2.5 milliamps. Now also, if you want to, you can enable DC mode, where you override the alternating current waveform and simply give a DC stimulation at whatever milliamp output that you desire. So it's kind of a manual control within a CAN protocol. It's kind of cool. Let me select this real quick. I'm going to disable this, and let's look at the actual protocol. When I go in there, you're going to see that the protocol is set up so that the primary stem channel is the ACS, and the secondary is an EMF if it's hooked up to the machine. Now with the ACS, it only looks at channel 1. Channels 2, 3, and 4 are ignored. Okay, so whatever numbers you see in the primary stem generator for channels 2, 3, and 4, they are not used for the TDCS, tACS unit. Only the frequencies you see in channel 1 are used. So we have 5 Hertz all the way down here. That's all that's going to be given in this protocol is 5 Hertz. Now if I had a EMF unit hooked up, you could look at the secondary stem generator and you would see that 5 and 40 are given, and it's alternating from, it's keeping 5 Hertz constant, but it's switching the gamma frequencies, it's pairing those all the way out. They're harmonically paired. Now back to the primary stem generator, if we look at the first stem cycle here, or channel 1, you can see it's 5 Hertz, 3000 milliseconds, and 0.05 milliamps. That's what it's giving for that one, and it's going to do that for each one of these unless you actually change it or override it. So all of these are changeable. You can go in and change anything. You can also enter into the protocol wizard, which we have enhanced now. We've made it so that you can step through the frequency, step through the duration, step through the voltage level. And if you want to, you can create protocols any way you want to, override what I've written, as long as you follow the rules in terms of the low end for frequency, which is 0.001 to 1,000, and the high end's 1,000 Hertz, and the voltage for the milliamps, which is 0.01 to 2.5 milliamps. So all these things are important to take in consideration when creating protocols. And really, when you're creating a protocol for just the TDCS unit, you're really only concerned about channel 1, but you do want to have values in channels 2, 3, and 4, because if there's any zeros in the table, the program will give you an error. So right now, just plug in any numbers in 2, 3, and 4. They will be ignored. They're not going to be used in any other way, but the system will look at them. You can put a voltage in of 1 volt, for instance, and you don't have to put step derivations. Just put some kind of frequency in there as well. Okay, so for this particular protocol, you see it's 5 Hertz, and on the secondary stem generator, it's going to be 5, and gamma from 40 to 80. So if I start this, what's going to happen is that the unit's automatically going to give each one of the stems, and it's going to keep on going. And if you see here, it'll cycle through each stem cycle, and you'll see the predicted frequency with the voltage displayed here. Remember, channels 2, 3, and 4 are not on here. It'll go through each one of these until it's done. And when it's all done, everything should shut off, and the measured scan should disappear. And it's done. Well, measured scan didn't disappear. Okay, but it is off. So if you wanted to, you could view the history and look in the history here, and you can see that we play around with this a lot. You can see what was actually given. It was continuous sine wave. The primary stem channels were the mastoids for channel 1 and channel 2. You can see what protocol was given. TDCS, ACS, CFC, 5, 40 to 80. You can write notes as you could in the past and associate it with each one of the protocols. So that's pretty neat. So I'm going to exit the program, and I'm going to turn on my X3000 unit, and I'm going to go back in, and this time we'll start it, and we'll go into DCS Database, start her up, and now you should see it sees a X3000 and a TDCS unit. We're going to go in there, and now if I run it, let's say I pick a protocol and I say, okay, well let's do our same one that we just ran. I can now, you can see you have a secondary stem generator, and I can change it to sign. I can enable or disable the override and set it up the way I want to. Select and close and run it. And now it wants me to pick a patient. I always have to pay. We have to make sure we have a patient. So now I select it and I start it, and now the stimulation is being given. And remember, the primary is the TDCS, and you can see that's running. The secondary now is the X3000 that's running simultaneously with it. And you can see that that's all going to work in the same way as it has in the past. And that's pretty cool if you want to give simultaneous treatments. You also have the ability to be able to run the RTZ. I do have a Q20 hooked up to this. I could set up my threshold pairs. Let's get some pairs. I set it all up here. It's ready to go. And I load and save it. Now it's ready to go. And I have a protocol set, and I can just start it. Well, there's nothing hooked up to the EEG, so we're going to see a lot of noise. But it's going to run through the same procedure as it always does. And it will start with the initial scan. It'll save that data, and then it's going to give a tACS pulse along with the EMF pulse. When it's over, it immediately scans EEG, and it's going to generate those Z-scores, and it's going to go back and forth. If the threshold values are met, then the reward tone is played. If not, it modulates to another frequency. This just adds a whole nother layer to operant conditioning by tying in direct current stimulation, alternating current stimulation, and pulsed electromagnetic stimulation, which is pretty darn cool. We're pretty excited about it. So when this is done, of course, the data gets saved. You can run it into NeuroPlot. There's a lot of different ways to review what you've done in a session. The dehabituator is also available for the tACS unit, and you can run EMF as well if you have the secondary hooked up. Just remember, you have to follow the rules in terms of voltages. So that means I'm going to run this at, let's say I run 100 cycles, 1 to 8 hertz, 1,000 to 5,000 milliseconds, and now I'm going to change my voltage to 0.5 to 2.5. And I'm going to start it. And did I enable the, let's see here. Oh, my EEG is still enabled. I have to make sure I disable that. Let's start that. And here it goes. It goes through there, and it starts, and now there it is. Now be cautious. If you set a range at 2.5 milliamps, it may start choosing random frequencies. It's choosing between 0.5 and 2.5. So some of these might be pretty darn strong and pretty darn jarring to a person. So I suggest really setting those ranges lower so that you don't overstimulate the person. And so if I was to do that now, I could set it to 1.5 to 1 milliamp and then start it. And there it goes. And again, it's going to start choosing different random waveforms for a different amount of time, and you can see these are all different sizes. Again, this is the actual stimulation that's being given, and it's not a simulation. This is what's actually being measured. And so you know what's actually making it through, which is kind of neat. Okay, and so this concludes oh, my battery's low. Well, I'm glad. This concludes the brief tutorial on how to use the system. I will be doing a webinar soon with more cases and more information. Thank you very much. Please feel free to post questions on the listserv, and we'll go from there. Happy holidays.